nozzle setup, and you take a fire load and you position it under one nozzle, between two, and then between four, and you run it at different ceiling heights, and you also run it in a corner. So here you have a 5-meter test in the corner. But no matter where a fire starts in the room, you have then proven that you can tackle the fire, right? Either with 1, 2, or 4 nozzles. So most tests are set up that way. After you run the test series, the accredited fire lab will issue a report. And it will tell you if you have passed the test requirements and what type of water density you had, how much pressure you used, what was the spacing. And that's how you would design the system. So for the office test, this is the part 7 in the new European document. Part 7 test, called the office test. Same setup, under 4 nozzles, move the fire load, prove that you can take it, temperature and loss of fire load. So you have to contain the fire. And again, you sit back with a report from the accredited fire lab. This is for residential tests. This is based on the original residential fire test in the corner. So the FM and the UL tests have one fire test in the corner, and then they run some water density. They measure how much water you have on the floor. With water mist, you can't measure the water on the floor, so you actually move the fire load around. So you have now in the Insta 900, there are 5 fire tests. One in the corner, then they move it under one, between 2 here, and then they put on a fan. And they put forced ventilation through, and then on the other end, they put the fan this way. So you have 5 fire tests. But on the new British standard one, which they improved, largely because we told them we wouldn't want to limit the room just to the room size. I said if you take down 2 walls here and make it open, it wouldn't have any impact on the fire. So they've done that. I'll show you a picture. Here's the fire load for residential sprinkler. 4 layers on the wood crib and these mattresses. Same fire load for residential water mist. Because actually after we ran the fire, we have 8 layers of crib. So you have double the crib size. Here's the open tests. So now we basically taken down 2 walls in the fire room, and you ran the test load, the fire load between 2 nozzles. You see the 2 here. These are our last tests that we ran. These nozzles are operating at 2.2 bar. So you're getting pretty low in pressure for water mist. The pumps that we used, again, pipe and pipe. This is not a requirement from the test lab to show the equipment that you use with the nozzles, but it's nice to have that as part of the test report so you can document it. And then again, you sit back with the report. Fire for parking car garage, same thing. You have the report. And all these reports then would make up your design, installation, maintenance, and operation manual. So this manual is what puts the basis for the training for designing, installing, maintaining our systems. And we do the training courses with that. It's not very hard. Any questions so far? Pretty straightforward? Yeah? Okay, switching gears a little bit here now. Water mist systems. You have basically the 3 same components that you use for sprinkler. You have the nozzles, you have a pump set typically. With our new nozzles now, you can actually get away with not using the pump set if you have enough pressure coming in from the mains. I was touring a little bit of Iceland around Reykjavik yesterday, and obviously you have a lot of water around here. So you may get away with not having a pump set in places. But most of the world would use a pump set, also for sprinklers. So we use the same type of pump set built up to the same standard as a sprinkler pump set would do. And then you have the distribution pipe work. And here we have different distribution pipe work availabilities. We secure them for the application, so you talk about residential, hospitals and care homes, hotels, sleeping facilities, schools, office, heritage. I think in Iceland currently you don't have that much in this area based on requirements. I think you have to build many stories for the government to say that you have to have a suppression system. Right? Is that correct?
4 stories.
4?
4.
Oh really?
Yeah.
Well, that's good. So if you build more than 4, you have to have a suppression system. That's great. So depending on, because here now, in Norway obviously, if you have more than 2 stories, you have to have an elevator. If you have an elevator, you have to have suppression. Okay? In England, you have Wales. Wales started up last year, all residential. If you build a house out on the, all by itself, have to have a suppression system. Okay? So Scotland, 18 meters, above 18 meters, have to have a suppression system. In England, 30 meters. So above that, suppression system. Of course, last summer you had the Grenfell Tower tragedy. Okay? So now England has really been pushing to escalate to get the requirements for lower. So Wales have been said to sort of lead the way there, and more is coming. So the trend is around the world. Sweden now are putting stricter guidelines in place. Finland has, and sort of following a little bit of Norway, what they have done already. So hopefully there will be more for all of us that live off of fire protection. There will be more also for residential. But I think for hospitals and hotels and schools and stuff, it's you have the same requirements as we would elsewhere. And then, of course, with the certification now, you know that there are suppliers that have successfully passed both the fire test and the component test, so there are alternatives to using sprinklers. We feel that then we are documented as a real alternative, documenting as good or better fire suppression with as little as 25% of the water compared to sprinklers. And again, I can say that because we have in fact done the tests that are based on sprinklers. Okay, so all these tests are baseline sprinklers. Smaller pipe dimensions make the systems easier and faster to install, and this is where we're winning projects. This is the key thing for winning a wilderness project. Less water requires smaller water intakes. If you do retrofits, a lot of, especially wooden construction, type wooden construction, heritage buildings are now being required to be retrofitted with suppression systems. So here you can save quite a bit with smaller dimensions, but also the smaller requirement for water into the building. Less water, less damage, shorter stoppage time, of course. Corrosion-free quality reduces maintenance costs. If you are have a client that is, say, a hospital or a hotel or somebody who's obviously concerned about not only the property but also the occupants in the property, this is a big selling point here. Even though you have top quality, I don't think you're going to win it with water mist unless the price is competitive. Keep in mind, few people would shop for a suppression system, right? Unless the government says you have to have one, you're not going to install one. That's as easy as it is, So really the market is where the government says you have to have one. I have this slide here in Norwegian. I noticed there was a lot of magazines out in the reception area, and there was a lot of Danish and Norwegian, and so I assume you have no problem reading this. I didn't translate this because this is paragraph 15.5 off of our technical guidelines in Norway. But it says that sprinkler systems or suppression and other suppression systems is an extension of the ordinary water installations. So you have to use products comparable to these, and it is contained in this paragraph. And then it says, as long as it fits. That opens for everything, basically. But it says that you have to put into place a possibility for exchanging out the pipe, especially pipe that is behind construction. So if you're behind a sheetrock like here, this ceiling here would be not permanent. Here you can have access to the pipe work, but anything that would be permanently concealed have to be exchangeable. It also should be protected from water leakage. So the water, if you have a leak in the pipe, should be led back to someplace with a drain, not to harm the building. So this is the code in Norway. All installations for sanitary have to be that way. Has to be exchangeable, have to be leakage proof, and you have to visibly be able to see the leak. Okay? I don't know if the same rules apply in Iceland. But obviously it's a good thing once you have the products for it. It works. But for some reason, Sprinkler has gotten away with not doing it this way. And it's hard to do because you have a bigger pipe. And you can't have it exchangeable. You can't have a pipe outside a big stiff pipe. You can't change a stiff pipe anyway, right? So that makes a big challenge. So you have small, 16 millimeter hot water, cold water, and then you have the sprinkler pipe right beside it. Now which one has the biggest chance of being punctured behind a wall? Right? Now which one gives the most water? Right? It doesn't make sense to me logically. I don't even get it, right? But that's okay. You can do that. So I say, okay, that's fine with the guidelines. And I'm not going to argue that you have to change the guidelines and disallow it, whatever. I'm just saying that if you can do it and meet them, the guidelines, then that would be a benefit. So that's why we have really focused in on this with pipe and pipe, and especially embedding in concrete. This is a typical apartment building, and if it's above then 4 levels here in Iceland, it will be the same. You build in concrete as well. That's the common way to build here, right? So through a waterproof shaft comes the water supply, sorry. From here you have the distributor. So you have a pipe and pipe from the distributor cabinet to each nozzle. Same dimension the whole way. You save a lot on design. You don't have to go here, here's a 40, there's a 32, here's a, to each nozzle, right? When you make an installation, as in Norway, Iceland has some weather, right? And it's going to change. So when you make the installation here, you have one connection in the cabinet, you have one connection out here by the nozzle. Anything between is whole wood. No, so you basically are limiting the way of making a mistake here for the installer. And trust me, mistakes are done. We're all human, so we make mistakes. So people are going to drill through. We had now the last project. It's one block actually. They're building 116 apartments, but on just one block of them, he had 7 drill throughs because he hadn't adjusted his drill bit to the right length. I mean, that became a huge job, exchanging all those embedded pipe, and with this system, obviously you can unhook the pipe in the distributor, hook on a new pipe, pull it out here as you're pulling the new pipe in. It saves tons of work. If you have a leak, obviously the water would run back to the cabinet. The cabinet has a drain out, and then on the wall you will see the water running onto the floor with a drain. So you're able to tell that there is a leak. But this design, it helps you in terms of both the design, makes it easy, minimizes the mistakes, and obviously it's corrosion free. The first pipe and pipe systems in Norway were installed over 35 years ago. They had a 35-year check on the system and it looked brand new. And that was for hot and cold water. Both hot and cold. Brand new after 35 years from using this material. For suppression systems, you're plus minus 20 degrees, constant. So it's very, very high quality for the application. When on the video, I hope you got on the video, you saw the technical room downstairs, the pump set by the water intake, and then we use stiff pipes out in the parking car garage. And then going up, you would use typically stiff pipe, or you could use an Alupex type pipe as the supply line up. But from then the distributor, from the shaft here, you go down here to the cabinet, you would just put down the pipe and pipe into each nozzle. Now, the elements that are twisted into place, already have these boxes here embedded in the concrete. So this box is, how am I doing on time here?
Sorry, is the cabinet so it's accessible, or?
Yeah, I'll show you that.
But it's also embedded in the concrete?
No. So I'll show you the next picture on that. The only thing embedded in the concrete when you host the element is this portion here, the red portion here. Okay? Then the element is poured at the factory. They know where to position the box. This is the kitchen, this is the, so they know exactly where the hole is, right? So now the element has about concrete up to here. Okay? So then it's hoisted into place. Installer comes. He has the pipe with him. So it goes, hooks it up here. And just connects it. This is a very simple system. Same system you would use for the sanitary. And you lock here, and you use the clip here to secure the pipe to the box. This goes back into the shaft and down to where the distributor is. I'll show you the distributor. Okay? Very simple. And again, this is used a lot in Norway and for a long, long time. Then they put the armor on top here, and then they pour the cement. The cement comes on top of this, and it's all hidden. Now if you have hindrances, say you have electrical boxes, what have you, it's not a big deal to just snake yourself around that, right? So for a designer, if you have an effective installation, you have to be very accurate in terms of lengths, on the pipe that you're going to put in. Here you have more flexibility in that the pipe can guide itself around obstacles. The coupling technique is again the same thing as you would use. This just expands the pipe here, so you have no contraction in the pipe. It's free flow of water. Big reason for why we chose this system as opposed to a stick-in system. Okay? No indentions here, free flow of water, and it's very safe installation. It's hard to make a mistake. You also use it if you have a suspended ceiling. So as long as the pipe is behind a fire retardant surface and it's wet, it's approved. Here's the cabinet. So the cabinet would typically be in the bathroom, could be in the ceiling, it could be on the wall. It could also, to save money, a lot of these big contractors now, they use the larger cabinets. And they would put this along with the sanitary, and they also have the floor heating. So it all depends. You have to do some separations, but they would invest in making the cabinet specially made, because they're making thousands of these apartments. But it's very simple. So you have the supply line here up to the distributor, and then one pipe going out to each nozzle. And like I said, finally we got the technical approval, the certificate from Sintef. And it doesn't limit it to residential application, it also includes OH1 applications. So we have a ways we can build upon this, obviously. If you think about a school or a hospital, going from the corridor out to the rooms on each side. Obviously it takes a lot of time between the cable and the electrical cable and ventilation and everything else to go with stiff pipe up and down and over. Much more flexibility with the pipe and pipe. However, if you have concealed space that requires protection, you can't use it. Because the pipe has to be hidden. Okay? A lot of references now. There are thousands now of these building projects going up, especially around Oslo. It started there. One of Norway's largest builders of apartment buildings have just prescribed the system since 2014. That's what they use. So now several others are coming on. And that makes, for a lot of installations over the last 4 years now. Of course, we have limitations. So if you came to me with a warehouse, sorry, I don't have the documentation. Others have. Others may have that. But there are documentation requirements, obviously. It's a performance-based system with water mist. So if you haven't tested for warehouses and storage, then, sorry, I can't help you with that installation. So that's just something to be aware of. Yeah, the green effect, smaller dimensions, I don't know. Most of you advising or consulting groups now are green companies, right? So you got to think about smaller dimensions. That's less use of material, more environmentally friendly transport, obviously, and storage. Less demand for water, not a problem here in Iceland, but for many other places. Corrosion-free system yields a higher quality, less maintenance, lifetime costs. You have Innovative solutions for the future that sums up to be a higher environmental standard in home, because you use less, essentially. Yeah, the nozzle lineup, we don't have to go in, but you have different type of nozzles for different type of applications. The different piping systems, in addition to the pipe and pipe, there's a lot of stainless steel, 316 stainless steel. There are CPVC opportunities, there's red pipe, and there are others as long as they're corrosion free. Keep in mind, if you're talking about embedding in concrete, especially, like this system here is approved for embedding in concrete, we can use this system. Tyco has another system, we can use that system. But we say every time, don't use this there, use this. It's a whole different quality of installation. Pump sets are built after the standard, so you have one for ordinary hazard. These are built by, it's our design, but built by Grundfos at the sprinkler pump manufacturer in Germany. And you have one for residential, these are the smaller systems. Then of course you have the monitoring. So the controller comes with a pump set, and that gives all the signals required for the alarm. These are again not different from the sprinkler, so the standard will be, you'll find the same wording in the water mist standard as you see in the, and you know in the sprinkler standard. So we follow the same. And I think I did pretty well on time, right? 9:01. Yes?
Would you ever have the system with reaction?
You can have, when you say the system, yes, 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 no. Here you have a wet pre-action,
Yeah.
okay? So in care homes, not care as much as we have asylum centers, and we're unstable people.
Yeah.
There you can have this system pre-action wet.
Yeah.
But what you do is you have a valve that would react then on smoke or 2 times smoke. Could do flame, but that's more expensive. That would open the valve.
Yeah.
But for these, it's the
So
same.
you'd only lose the water that's already in the pipes?
Exactly.
Yeah, okay.
So one asylum center was really happy. That was with this system though, that we did that, or we suggested doing that, because the first week after they moved in,
Yeah.
they were doing swings,
Yeah.
what are they called? Gymnastics in the pipe. And of course they tore down the pipe, but they only got the water in the pipe. There was no heat. If they knew that they would do smoke in addition, full-blown operation. Yeah.
Can we do not to make a short coffee break, or not know if you're almost done? Is coffee ready?
Okay. It's up to you. Yeah. Yeah.
Just one question.
Yes.
Did I understand you correctly that this is more expensive than other solutions?
I'm very glad you asked that question, because then I have not done a good job. Because we wouldn't be able to sell any systems if the price was not competitive. It has to be competitive for us to be able to sell the system. That's just because the owner that buys the system, they have to have it. And typically, they sell it afterwards, so they don't care of the quality, as long as it meets the standard, right? It's okay, right? So we spend now a lot more time as we're starting now to marketing this. And like I said, we've been doing this for 10 years, and building up in Norway, and we're a profitable company, so we can invest in research and development with our operations. But now we're focusing more on the owners, telling them that you don't really know what you're buying, right? Because when you say a suppression system, is that a Fiat or is that a Mercedes you're buying? They don't know if you're going to get galvanized steel, if they get black steel piping, or if they get a corrosion-free system. It's all up to the installer, right? Because they are just basically saying, I'm building this office building. The fire consultant says I need a suppression system. Okay, we need that. Get the bid out. This is a suppression system according to 12845. Okay, perfect, great, done, right? Well, they don't know what they've got. What do you think the installer is going to come with? What they make most money on, right? So if we can do the same price with these type of systems, because we can't use galvanized or steel that rusts. You know, we have to have clean water here. But then you have a whole different sustainable system over time, of course.
Are you cheaper then?
Yeah. To put it this way, see, I'm the provider of the components, right? Somebody has to design it. It's not me. Somebody has to trust me that the documentation I put forth, yeah, that's valid. I can put my name on that. I'm the designer. I'm responsible to the authorities that this is a system is as good or better than sprinklers. That's the standard. Now though, suddenly I don't have to say that anymore. I can just say it's according to the standard, right? But then somebody designs it and then somebody installs it, and the installer will come to us. They'll say, Eiling, it's a little more expensive, but we'll do your system here too. Yeah, just because I'm a nice guy? It's because they make more money off that, right? And the client at the top, the price is the same. Keep in mind, they don't know. They don't know what they're buying. They just need an approved system. So the price here is the same. It's all how you divide it going down. And as you start to get into that, people understand. And when the component here, if you use comparable components, we're cheaper than sprinklers because we use smaller dimensions. And if you look at the pricing of piping parts, it goes like, you know, that. The bigger the dimensions, it goes dramatically up. So if you can keep two sizes below on average, you're going to save a lot of money. A pump set is required in many countries, whether you have sprinklers or water mist, so it doesn't matter, right? But the nozzles, our nozzles cost more than a sprinkler head. But what costs most is time. So the installation. And if you can do this, live example, one of our dealers in Norway had 4 apartment building blocks they were building. The first one was already designed with residential sprinkler. Did that. Came back to the owner and said, the next 3, we're doing water mist. They said, okay, we'll do that. And that's the first time I got the feedback saying from him, because typically they don't say what it costs. And he wouldn't say what it cost, but he said, we used 20% of the installation time. Saving 80%. Now that is with the piping pipe embedded in concrete, okay? Which is a lot quicker than if you just do it concealed, you know, suspended. But 80% making, in Norway, pretty high hourly wages. That's a big, big savings. And like I said, I showed you those references of these projects here in Oslo. When you see these, the reason that we got, this is Selvåg, this is Selvåg, and this is not Selvåg, this is Bundebygg. This is next to the others. And they came to us and go, or actually they came to Selvåg, what are you guys doing? How come it's so fast? You done already? And that's how that ended up. And so it's sort of, you know, builds on that. But again, if we weren't price effective there, no, couldn't sell it.
What about the test valves needed for the systems?
That,
Where you put the test valve at the most difficult point of the system. Would that just be in the box? Or?
the test,
It's according to the standard, you need to have a test well at the end, far away from the technical.
yeah, you can have that in the here. You can have a shut off here.